did I put my book?
Right there, it's on your desk. You just have it.
I just got to get things set up. Okay, so what we're going to take a look at is 119B. 119B, we're asked to solve for the pH. And we're on page 706. So we have 0.050 molarity of, this is considered a salt, the NaCN. Okay? NaCN. Alright? So this is what happens when it dissociates or breaks apart. It goes from NaCN solid form, dissociates in water to make Na plus Cn minus. Okay, now when this is a the Cn minus is a anion of a weak acid. It's an anion of a weak acid. So what it's going to be is a conjugate base. So when we take, for example, in a reaction that has the acid of HCN, so let's say we have the acid, we don't. Let's say we have the acid HCN plus water, it produces H3O plus Cn minus. And if you remember, this is the acid because it's a proton donor. This is a base. I need to put aqueous there, liquid. This is the acid on this side. We call it the conjugate acid. And this is the conjugate base. Okay? So what happens is that if we dissolve a salt that has a cation, which is Na, is the cation, of a strong base and an anion of a weak acid, it creates Na plus ions in this case and Cn minus ions. So the Cn minus ions it's basic. So the Cn is going to react with water to make a solution that is basic. Alright? So this reaction here is not taking place in our solution. I'm just writing this out to kind of refresh your memory on what an acid is, what a base is, what a conjugate acid, conjugate base. This is that exercise we did on the computer where we took cation of a strong acid, or strong base, and anion of a weak acid, and we know it makes a basic solution. So this is going to make a basic solution. The Cn minus is going to act like that conjugate base. Right? So what we're going to do is when that's in solution, this is what's happening. So when the NaCN breaks apart, it has Cn minus ions floating around. They're going to react with water to make HCN plus OH minus ions. Okay? So in this case, this Cn minus is what? Considered what? An acid or a base?
Base.
Okay, why is it a base? What's the definition that causes it to be a base?
It receives the electron.
Right, it receives the proton. So it's a proton receptor or acceptor. So this is the base. Remember, when we dissolve HCN, just HCN, that it made a conjugate base, and this is what it was. This becomes the acid because it is now the donator of a hydrogen ion. And then this becomes an acid on this side, we call it the conjugate acid. And then this is the conjugate base. Any questions you have with this setup? Okay, so I wrote 3 equations out. Alright? I wrote 3 equations out. This is what's happening in the water. Okay? The HCN is breaking apart to Na plus and Cn minus. So that's what's happening in the water. If I had the Cn minus that was with the H being a weak acid, it's going to react with water in this way. Okay, so this is not happening in our solution. I'm just showing you that because that's what happens to weak acids when they would break apart. Okay, this is the one I'm going to work with to do my ICE, okay, or figure out my answer. So then I've got my ICE, and I want to find the pH. So then I'm going to take and write the concentration of the NaCN here, because it breaks apart 100%. And so the concentration is 0.05 molarity. Okay? This is a liquid, so it doesn't enter into our Ka, or this case Kb. We're gonna, because it's gonna make a basic solution. And then these are 0. Okay, so then we have 0.050 molarity minus X, X, X. Okay, and I messed up on that, didn't I? Because this should be just minus X, and those should be X. So I get in a hurry sometimes, and I want to do the equilibrium right away. Okay, so that would be minus X. So then we got 0.050 molarity minus X, X, X. So what that leaves us with is finding, we've got to find the X concentration. So we're going to set that up by saying that Kb, now why is it Kb? Because it's going to form a basic solution. So I'm going to say Kb equals the HCN concentration, so the products over the reactants. Okay? Any questions with that? So that's what we're going to have to do, and we'll substitute in our X and our concentration in there when we need to. Okay? So this is what I was telling them. If you go back to page 658, you do that. You got to find the weak acid that HCN, that CN was in. So HCN is on there, and so what's the Ka value for that? 6.2 times 10 to the minus what? 10. Okay, so that's the Ka. Now, you guys have your packets. You should have something that looks like this in your packet. It says Kw equals the Ka plus the Kb. Or times the Kb, I'm sorry. Times the Kb. Okay, if you look that up, that'll be in your packet. Now the Kw, they'll tell you what the constant is at 25 degrees Celsius. So Kw equals 1 times 10 to the minus 14th. So we can set it up. We can say 1 times 10 to the minus 14th equals the Ka, which is 6.2 times 10 to the minus 10th, times the Kb. That's what we're looking for Kb, because if you look here, the HCN, we need to use the conjugate base of the HCN, and so this equation here allows us to find the Kb to plug into our equation. Okay? So what would that equal? Taking 1 to the minus 14th divided by 6.2 to the minus 10th. What's our Kb going to equal?
1.6 times 10 to the minus 5th.
1.10 times 10 to the minus 5th. Okay? So what we'll do is we'll bring that back to our original setup here, and that'll be our Kb. Alright? So that 1.6 to the minus 5th is going to be our Kb. So I'm going to put 1.6 times 10 to the minus 5th equals, it's going to be equal x squared over the 0.05. Okay? So that is it, our KB is 1.6 to the minus fifth equals x squared over 0.05. I multiply that by 0.05 and I get, and then I take the square root of it. And I get 8.9 to the minus fourth, right? So x here is equal to 8.9 to the minus fourth. Okay, minus fourth is what that's supposed to be. Okay? This is by far the longest type of problem that we've set up when we do titration. So you're going to have to try to stay with me the best you can today and ask questions as we go along, because it's a long process. This is the longest type of problem you'd have to do just because of everything involved. Okay? This one's not that short a problem. So I've got x is equal to, so x would be OH ions. So if I log that number, if I take the log of that number, okay, I take minus the log of that number, which is 8.9 to the minus fourth. I'm going to get the POH. And that is 3.05. So the pH is going to equal 3.05 minus 14. Or 14 minus 3.05. Okay? And so I get an answer out that would be 10.95. Is that the answer in the back?
Yeah. It's,
Okay. All right, so that's the pH is 10.95. Okay, I want to review this real quick. Okay, so hopefully you guys are paying attention. I know that these periods are a little bit longer, but I have to go through it this way. Okay, so we'll start off with our ICE. It dissolves. It makes Cn minus ions, which are going to make a base, react with water to make conjugate acid, conjugate base. Then what we can do is we can go through our ICE to solve for X. When we solve for X, that's OH ions. Okay? But we've got to find the KB. And what we do to find the KB is we go ahead and look the original up and we say KW equals KA plus KB. We go ahead and take the KW divided by the Ka, it gives us the Kb, and then we can solve for the hydroxide ion concentration. Okay? So we'll see another one of these here in a second, but not right away. Okay, any questions that you have? All right. So we're going to do a problem that we're going to go through, and I need to use probably acetic acid because that's what you're going to titrate. Okay? So I'm going to use a solution of acetic acid to titrate, and we're going to go through the steps to do that. Okay? So this is what you're going to do today. Just like we did the other day, you're going to titrate 10 milliliters of acetic acid, 0.2 molar, with the same concentration of NaOH. That's what you're going to do. Okay?
Is this like the problem with it?
This is a different problem. This is one where you're titrating a weak acid.
Yeah, the one that we did 2 days ago.
2 days ago was a strong acid.
Okay.
And it's a different process. Okay? the first thing I need you to do for me, and everybody can do this, okay, is I want you to figure out the pH of that weak acid. Okay, so the Ka value for acetic acid is 1.8, or I'm sorry, 1.8 times 10 to the minus fifth. I want you to find the pH of that solution.
The 0 milliliters, is that supposed to be for the NaOH?
Yep, 0 milliliters of NaOH added. So we haven't added anything. So we put our pH probe in there. And we detect what that would be. You can't just log that number. If you're logging that number, then your answer is going to be wrong. Because you can only do that with strong acids. So then the Ka is there. If you remember, Ka equals your H plus which would be your concentration you want to solve for. And then this would be A minus. This is just a generic setup of that. Divided by HA. You guys set it up with that. Okay? Go ahead and do that. You should get 2.7 for your pH.
Would that be pH or pOH? Oh, yes, never mind.
Okay, do you want to see that worked out? Is everybody getting that? Oh, you do. Since it's a small constant, you're going to put 0.2 molarity down here. Up here, you're going to put xx, or x squared, equals the 1.8 to the minus fifth. So then you take 1.8 to the minus fifth times 0.2, take the square root of it, you get an answer out. That would be 0.001897. You log that number, take the negative log of that number, and you get the pH. It's 2.7. Any questions with that? So when you put your probe in there, it should read around 2.7. I know that our probes that we've been using are a little bit off, but they were fairly close. They weren't off too far. Okay, so any questions before we do the next part? Okay, all right. Now what we're going to do is go through the process of using our ICE. Okay, so on B, what we're going to do is we'll add, we'll just add 3 milliliters of our base. Okay? So add 3 milliliters of NaOH. Okay? So we have our equation that says HC2H3O2 plus NaOH will give us H2O plus C2H3O2 minus.
But
I'm sorry, this should be H3, H3O plus.
What's the molarity?
No, that's right, H2O. Oh, and it's supposed to be Na. I'm sorry,
yeah,
Na. C2H3O2. Okay? Question.
What's the molarity of NaOH?
0.2 molar. If you remember, we plugged moles in, right? You guys remember we did that? We didn't do molarity. So the moles of HC2H3O2 we had to begin with is how many? 0.002? And then we added OH to it, and we added 3 milliliters, so that would be 0.003 times 0.2. And so what do you get? 0.0006. If you remember, we subtracted. So we went 0.002 minus 0.0006. We got an answer. And of course, this would be basically, they're canceling out because it's the same. So this is 0. And then we get a number of moles for this that would be 0.0014 moles. Right? What we also have to do that's different in this one is realize that the C2H3O2 is going to counteract this the acid. Because now we've got C2H3O2, which is a conjugate base, to this acid. So that creates a situation where we produce 0.0006 moles of the NaC2H3O2, which is C2H3O2. Okay? So find the molarity of both of those, if you would. So we have 13, so it'd be 0.013. So we got 0.0014 divided by 0.00, is it 0.013, right?
Yep.
What'd you get?
0.108.
0.108 molarity. So this is 0.108 molarity. Okay?
Which one? For each, yeah.
Is that what you guys got? Because I'm relying on you because my calculator went. Okay? And then the 0.006 divided by 0.013 is 0.046 molarity. Okay? So, what we can do, I want you to look in your packet. So we got the pH to begin with. Okay, we've got that figured out. We went through that long process to figure out two concentrations. Our Ka still is going to be 1.8 times 10 to the minus fifth for acetic acid. Do we have any H plus ions floating around in our solution?
No.
No. They're in water. Water has all the hydrogens. Okay? So we don't have any H pluses. So right there, that one is not going to enter into our equation. All right? So we're going to be left with A minus and HA. Do we know the concentration of our A minus? Do we know the concentration of A minus? So this C2H3O2 would be our A minus.
Yes.
Well, how would that be A minus?
Well, because the Na, if you take it away, it's a spectator ion. So if I wanted to take the spectator ions out, then we'd be left with HC2H3O2 makes H2O, and then we'd have C2H3O2 minus ions floating around. Okay? We know that, right? It's 0.046 molarity. So that would go here, 0.046 molarity. Okay? All right. And I messed up, and I apologize. So I'm going to write this again because I said there's no H plus ions. There are some ions, but they're really small. Okay? So again, I apologize for that. I shouldn't have canceled that out. Okay? So disregard what I did here. So we know the A minus. We're going to plug that in. That's 0.046 molarity. Is that right? Okay, what's the HA concentration? 0.107 molarity. 108, that's okay. And then that equals 1.8 times 10 to the minus fifth. So here's my H plus ions. If I solve for that, then I can solve for the pH. So go ahead and solve for H plus. If you log that number, that gives you your pH. So did you get 4.2 to the minus fifth for your H plus concentration? Anybody not get that? So we're solving for H plus, so we multiply 1.8 times 10 to the minus fifth times 0.108. We divide by 0.046. We get that concentration. We log that number, and we get an answer. It's 4.3, right? 4.4. Any questions with that? Next thing we're going to do is we're going to go the halfway point. It's called the halfway titration point. So we're going to add 5 milliliters. That'd be half, right? Okay. So this one's really easy. The halfway titration point, all you have to do to find the pH is to log the Ka. And I'll explain why. Okay? So if we know it's at the halfway point, the halfway titration point, okay? So what was my original concentration? Or moles? 0.002. And then this was, if I add, this would be 0.001, right? If I take 0.005 times
Yeah.
0.2. So that's halfway titrated. So then this is 0, 0. Then we take 0.002 minus 0.001. We get 0.001. 0.001 minus 0.001 gives us 0. And then over here we make 0.001 moles of the C2H3O2. So here's what we have. We have H plus. Then if we would divide that by the total volume, 15, we'd have 0.067 molarity. And this would be 0.067 molarity. And they cancel out, right? You guys remember we did the halfway titration and we said if you just do that, then you can figure out what the Ka is. So when we do the halfway titration point, we can figure out what it is. So all we do is log 1.8 times 10 to the minus fifth to get it. So go ahead and log it.
4.74.
So the pH is what?
4.74.
4.74 is the pH at the halfway point. Now remember, write these down because you're going to be titrating these here. Okay? So write these values down as we go. 0, 3, and 5. Okay, the last, we got 2 more.
Oh my
I know, it's a long problem. Okay, then the next one is where we're going to titrate it to where it's equal. Okay, and so you're assuming that you'll get a pH of 7. You don't. Okay, when you do this. So when you titrate it, this next part, you got H, C2H3O2 plus NaOH. Get Na, we better do it in the same order. H2O plus NaC2H3O2. Okay. So when you do this, you have your ICE. And we know it's neutral. So this is 0.002. Is that right? And this is 0.002 when we add where it's equal. So basically, we subtract out 0.002 on both of those. And you end up with 0 left over. 0 left over. How much C2H3O2 will you have left over?
Is this where we add 10 milliliters?
What's that?
How much did you add?
That's when you add 10. So this one you can put down, add 10 milliliters. Okay, how many moles you left? How many moles do you end up with C2H3O2? 0.002. Okay, so find the concentration of your C2H3O2.
What is the NaCTH3O2 like equilibrium? Is that just the same as
What's that?
like the NaCT whatever?
This one?
Yeah.
Yeah, that's the ions you produced. So what happens? That's going to be your plus X on that side. So
Okay.
here's your X,
Right. Okay.
then that'd be your plus X, and you got X. It'd be moles, and so you divide, go 0.002 divided by 0.020. Is that right? Liters. And what would that be? 0.1 molarity of the C2H3O2. Got it? So now you got to find the KB of the Ka because we have the same problem we started off at the beginning of the class. Okay? So the beginning of the class we have KB equals Ka divided by, I'm sorry, KW divided by KA. So go ahead and find the KB. Ka is 1.8 to the minus fifth. So you're going to take 1.0 times 10 to the minus 14 divided by 1.8 times 10 to the minus fifth. You're going to come up with the KB. What is it? 5.56 times 10 to the minus 10th is equal to the KB. So now we have this set up. 5.56 times 10 to the minus 10th. That's going to equal x squared, which is one of those x's is going to be OH, divided by the concentration of our solution, and we said that concentration was 0.1 molarity of the C2H3O2. Then we solve for x. X will give us the OH minus ion concentration. And then if we take and log that number, we're going to get the pH. Oh, you're right. I'm sorry. The POH. So go ahead and log. So it'd be basically your logging. So that would be 5.56 to the minus 11th.
It'd be the square root of 5.
Right, right. But I mean, that would be the square root of that when you figure out your hydroxide concentrations. And that would be 5.1, is that right? So the POH is 5.1. So the pH is equal to, what, 8.9? So when you get it pink, or get it neutral, you'll get an 8.9 out. Okay, there's one more I could do, but I'm not going to. Okay. All right? So, any questions you have on that? So what we'll do is have you titrate. Put it in at 0, add 3, test it, add 5, test it, and then add 10, test it, see what we get.
What were the pH values for 0 and 2?
Okay. We have them. 2.7 and what? 4.3. Okay. That took 38 minutes to do.
Good lecture, Dad.
I don't know any other way to do it. Other than to have you look at the problem. If you couldn't follow along, you didn't write stuff down, you got lost, turn to page 731. There's 731, what you're doing. 731, 732, and 733. And then they go to 734, which we didn't do E. Okay? So, guys, partner up. I think we got even partners, right? And titrate. We'll have the base out here, and you do it the same way. Okay?
You did a good job yesterday. Except for a few kids.
Yeah, I know. It passes.
Hey, guys. So you can get this done.
There's only a couple.
Wake up.
Oh.
We're down 50 to 43.
What?
I brought us back. That's why it's back to the lead right here. This is for. Is that their 60? I think we covered your ass.
Oh, I need a
Tell me to demote Jared. We need Jared demoted. Where are we going? These two.
Hey,
Hey,
here's the base.
Base.
The
We're going there.
yeah. Get that. Get a pH probe.
that's actually.
Hey, I'll get your pH probes. Yeah, don't take them. Just get a. Barrettes are down here.
Well, that's mine. Where'd you find them?
In that drawer.
Well, I think we're good. We're done.
Dylan, where's yours? My glasses? Yeah. On the other side. Oh.
What are we doing?
You got to fill the barrette with the base first.
Where's the base at?
He's got it.
All about that base. About that base. Oh, we're gonna do it.
Lick it. Ooh, love a beater. Lick it.
What are you getting, Jelly Beans? Oh, okay.
Look at that. I'm gonna
So
use that.
won't you
Get out of funnel.
stay with me?
Okay, for a small apple.
Why does that work?
Air pressure. If you try and drain it without having airflow coming in, then all you're gonna do is just make
Because
negative air
it's
pressure.
gonna force them out, then it's gonna stop because it needs air.
Thank
See,
you.
he gets it.
Teach. Appreciate that.
You know why? Because when I like fill up my lawn mowers with gas, sometimes I forget to take off the back catch they
Guys, I can't count properly, so I'm gonna fill it all the way to 50 so I can be
or
lazy.
the nozzle, whatever part of
But I don't like
That's
this
the
rack.
back thing.
Alright, we're not using this one.
We need to be here today to cook. What?
Oh, ice cream. No ice cream Friday for me.
In my one class, there's a trout, the eighth grade came in, and he goes, so that's how you cook meth, that's as right as they want you.
No, maybe just two.
And Mr. Wells wasn't very happy.
Oh shoot, this is a weird one. Do we not? We don't want this one.
That's yours.
I don't know, I'm sorry.
Maybe this is
I'm sorry.
District music.
Gag, Dad,
Yep.
why do we have district music? Just
We can't do.
so you know. FYI.
Next Friday.
Yeah.
There'd be
And
two
that's
people
gonna
here.
leave you Dilly B and
Tyler.
Tyler.
Couldn't get this done.
I think we'll make ice cream today.
No,
Yes.
no,
Yes.
no.
That's what.
Booyah.
And that's where.
How did I get stuff on me?
Oh,
You know what, whatever. It's relevant. What am I doing now?
Crying.
Yes, hardly.
Oh, dude, I am good.
Exactly.
Give me a medal.
No.
Oh.
I leave it in on the bills for being lucky.
Let's go, man. Now what? I'm confused.
I need to find something that measures 10 milliliters. Yeah.
We don't even have the other thing out yet. Nailed it. Got it. And I swear. No, he's gonna get him out, he said.
I was gonna get a lot more.
He said he's gonna get him out.
Where's the acid at?
That's what we're waiting on, bro.
Had to make it up.
Oh, okay.
So here's the acid.
Boom.
Look.
Come up and get a little bit.
So much acid.
Huh?
Come up and get a little bit, enough to do a couple trials if you need to.
What the heck?
This is so.
10 milliliters?
Yeah. Yep. Whoa, whoa. Let's keep it on the DL.
Where?
Oh.
What did you do?
Got it.
Oh my god.
You guys need to use the pipe. You guys need to use the pipe vent to get it out. Don't use guys with cylinder.
Oh.
Use the pipe vent. So I said get enough to where you can get it. You guys need to use pipe vent pump. They're a lot more accurate than, because it leaves behind, if you pour it out, it leaves behind some acid.
Those kind of cylinders are the
Oh, that's my phone.
pumps. Hunter, you got this. I can't do the pumps.
Good, for me.
Pumps work.
We'll go.
Dos, tres, cuatro. Listen up, y'all.
You're the one that's.
Oh, you have it.
Why are you blaming stuff on me?
Is it good?
Easy, probably.
Virgo,
gotta
she's
get
got
it.
the vicious cycle.
Why does it not go all the way?
I'm the F, E, the R, G, the I, the E, and holy, put down my, why are you so far?
As far as the measurements go, I'm
Yes, because that's how I,
Go high.
no, I was talking about Dylan, he was like measuring something.
We need to do that.
How do you get this thing so I can get?
Push the air hole so you can let air out without pushing water out. So push it, push your thing down.
And then after we figured out how to do it,
A lot faster. And I'm gonna have a really bad war when it's good
okay, let's go, man.
You'll have to wait until I get this calibrated.
Can't no lady put it down like me for delicious.
No, it's actually not that nice. Well, okay, the 560s. The 560s are the
Here's
decent.
the 600 if we win.
Huh?
I tried to put my head in, it didn't work.
But we never win.
I thought they were all the same
Except I
size.
got us to win.
1500 dark
Hold
woods.
up, check it out. Baby, baby, baby. Heath, what's for lunch? Check today?
You know what's
What?
Yeah, I didn't want
Check today?
I haven't. I didn't check.
Okay.
Who knows what's for lunch?
Benny.
Oh, we should put that in.
Check 6, tried to attack me, tried to get 3 numbers and we got 48%.
This can go down.
So he could
Oh,
have attacked
yeah,
on you
second.
guys and probably got, because he had 10 level 3 dragons, so he could have.
Did you see Jacob Wright's comment?
Yeah.
Jared's like, he goes, why did you attack their 3 threshold? You were 2 and you should have started at 1 and 2.
Get good.
And then here's Jacob Wright, boy, she's attacking
give less than crap.
Ben plays it now.
Clash.
I just don't have the will to.
Oh, it takes the frickin' ever.
Yeah. Exactly. I don't never vote.
I don't even understand it. It's just like kill people.
Especially like where I am now, it just sucks. You have to wait till you get enough elixir to upgrade stuff, or gold, upgrade stuff.
I am not
Struggles.
Here, you guys try this, and you see how this works for you.
I'm not much.
And then I'll get you guys yours. So you guys will share this one?
Need to
Test
share?
it?
Sharing is
Sharing is
Dirty
for
left.
losers.
Sharing is caring, unless if it's STDs.
And that's not caring. Swings it around.
Who's got?
Or communist when that's when it's forced.
Actually, it might be just better you want to. Yeah, it's been.
No.
2.17 supposed to be.
There's 13.
What was you supposed to have?
2.7.
They're at 2.4.
One attack.
2.45.
And then there's 17.
It's pretty good.
Let's see if we can.
Now, I made it up, so it's definitely you guys are messed up, not me, so.
Oh.
Can't no lady put down like me for malicious. I put that boys on rock. It's not even on the block. Just
Okay,
watch
this is yours.
what I got.
Okay, and then I need to get your pheno saver.
Yeah.
Yep.
Baby, baby, baby. If you ever want me.
No.
Oh, look at
Actually, I
that.
see them
2.4.
flying.
5 Zoe.
We did. I don't know. I just didn't.
Okay, you're just flipping it, is what you're doing, so one always goes with
Okay, now
grams,
how much you
47.8. So what you're doing is you're putting
Alright,
grams here,
tall person, you up.
and down here you're putting kilojoules, and they won't cancel out. You have to put grams down, so you have to put a G down.
So it's always like, if that's like kilojoules.
Yep.
How old
Yep.
are
Yep.
you?
It always goes like that, it always goes like that, yeah.
So like that one.
Well, this one here, you had to use the density. So this one, you have to have a change of grams, so then you can use this value
I don't
here.
think you said it.
Dad, do we have an indicator?
You don't need it until you get to around 10, so you can add your 3 and then test it. So 5
Golden.
millimeters.
Nice
Down
job.
here,
Nicely
you're
done.
your point
Maybe
7,
please use
or
the
your
same
1
job.
millimeter, and then all you put your point 7 grams. So by doing that, you can figure out your grams.
Find me a
strawberry. 50 milliliters and then you put 1 milliliter.
Yep.
And then
0.74, and then if you get a value here, and with this value, this will be grams, and you set it up just like this one. So you put your value, I
There you
think
go,
it's like
sir.
30,
Hey,
say
thanks.
37.
What is it supposed to
So
be?
then that's 37 grams, and down here you put 1
Go,
gram.
B.
and then 40
Come on.
Does that make sense?
Go.
Yeah, you're gonna be.
Yeah, but it's like
Hey, why is your paper on it?
Wait, what did you guys get?
3.92.
4.1.
Alright, there's no way that we're so close with. Oh my god, we're at 3.95, seriously?
Is it 5 next?
2.5?
So you just put 2.5, right?
What?
Like you just add 2 more milliliters.
Right, well, you multiply by 2
Baby,
because
baby, if you
you have 2
really want.
gallons and you have 1 gallon is equal to that.
Hold up.
So originally, the main thing is that you're setting these up, that your units cancel out. But yeah, you'd multiply that by 2 to get your 5320. Then your 5320 would go to here.
Oh, it's
So
4.
you go 5320 and then you put 1
I was
gram and
eating.
kilojoules up above.
4.7.
But I mean, you'll have to multiply by 2 so that you.
Boo. Always points.
Yeah, before you even do it. Yeah, because you have, this is 1 gallon. So you multiply 2 to get to. Yep, yep. See how you have.
Slow down there.
You said this
Don't
one.
go over.
This one you got right. And this one you just have to divide by 1,000 to get it into kilojoules. Because there's 1,000.
Is this when we need our
1,000
indicator?
joules.
When we go to.
I thought it was.
Yeah.
Yeah, because this is joules per gram, and this one's kilojoules per gram. So then you gotta say, well, there's 6,081 joules,
What's next?
so
7?
it'd be 6.081 kilojoules. That's all.
Wait, is this
Same amount, so we'd have to put in 5 more.
Yep.
We're supposed to have the integrator.
Then you wouldn't have to do anything.
Wait, wait,
You
wait.
don't have to do anything, because you already have your units, but they're in kilojoules per gram.
It's your 85. Oh yeah, so now we do 10.
Oh, we need
Look
indicator.
at that one here, and I'll go through that one with you.
We need
Right,
indicator.
right. So do we,
You're like 1.5, I think so.
what did you get for your 5?
It'd be close to something.
Supposed to be 4.7.
Would you guys, is it coming out fairly close?
We're 0.2 off, 0.23
But that-
off.
But I mean, they're going up, they're,
Yeah,
is the
they-
difference about the same as what you started with? They're low?
Oh, yeah.
Yeah, we've been maintaining
Well-
about a 0.4 difference. Alright, where's the indicator at?
Over here.
So bossy.
I was just asking where it was.
You didn't say give it to me.
Exactly.
Would you guys get that?
About the same as this.
Okay, on this one is,
Hey, what was the second?
I'll just get a hanger.
you put your 949 out in front.
I think you're supposed to have 7.
Oh wait, it's
The
3.
density of water is 1 gram per milliliter. So you take 949 times 1 gram over 1
And
milliliter.
then that was.
Milliliters cancel out, you get grams. This answer should be 949 grams.
Hold up. Check it out.
Because your density of water is 1 gram over 1 milliliter.
27,
Yeah, 27 you're
Good job,
doing here.
man.
So this is 27.
49 milliliters.
Yeah, and then for water, it's for every 1 gram, you've got 1 milliliter. So 1 gram would go on top for 1 milliliter, and so it'd be the same. You need 949 grams.
This is every subject I just got.
And then,
Nice. So
That's
mine.
why I've never
and
done
then this,
That's
so,
what mine looks like, so.
so for 29, I take.
Was it supposed to be?
Well, you gotta do 28 before you do 29. So 28, you have to determine how much energy is gained by the water. So that's that equation where you take the weight of water
Said go to 10.
times 4.18.
I think it's supposed to go there.
4.18.
10 milliliters.
No, we're
Yeah.
supposed to go to 10, but I wasn't sure if we were supposed to go before actually stopping.
Yeah, and then you take and multiply it by change in temperature.
Oh,
That is not good.
ours is way off.
Yours is like, ooh!
They got about the same. Maybe a point difference.
What'd you get for C, or the
Weight of the water.
third
So
one?
you're basically using this equation,
Would
right?
you use the third
8.9,
one?
right?
Yeah, like 5.
We used in the lab.
Well, so it's just the. so-
Just change in temperature times
oh, yeah,
4.2
Baby, baby.
What?
If you really
times
want me.
the mass of water.
Hold up.
That's going to equal your heat.
5 milliliters?
Yeah.
It's just a finger till it's just 10.
We got.
Then, to find the heat of combustion, you take that number divided by the number of grams you have.
What'd you get?
So, so I got this right.
Yeah.
Wait.
Yep.
No, we went past. We measured it and then we're like, oh.
Alright, let's write it down, because we can go with
And then, so for
Huh?
29,
You can write it down.
I take
I
that.
already did.
It's probably gonna,
5.32.
probably gonna go away right soon.
Baby, baby, if you really want me.
Why did I put another 4?
You listen to Fergie, Jared?
That's like 7.
Oh, of course.
I can't believe that anybody listens to Fergie and
Fergie and Scotty. Her songs are so dumb.
Take it.
They're all about herself.
What's going on?
You don't have to use the train tracks on everything. Because this one, all this one is, you take the joules and then you divide it by
10 milliliters, it
the number of
would be.
grams.
Yeah.
So it's just 148,000 divided by 2. How did that turn out?
10 milliliters did not go to 8 point whatever.
It brought us to 5.
We got
How did it
5.
turn pink?
No.
No,
Oh, then you get it to pink.
That's what we,
Yeah,
that's too,
Uh,
I
that
feel
is
like
too
that's
light.
too here.
I
That'd
got
be
like-
fine, that'd be good.
I got that.
3 drops fast.
Get it to pink.
You got this. No pressure.
Thanks.
I guess more than 3 drops
baby.
fast.
Oh
considering
my
that's how-
gosh.
Go ahead and test it, see what you get.
On the F to the E, R, G to the I.
I've never gotten a good tank. I have, but it was, I think, better now.
I think that's like,
How much did it take?
This time, when I got the dark paint, a little bit past 11 for me.
I got like 13.
Victory!
No, 12 and a half.
Yes. Got the dub.
let me see. Yeah, that's 10.3.
Mine's 11 and a half.
10.3, what did you do?
go.
Yeah, 10.03.
Let's go.
Let's go.
You get pink.
Do what, do another thing.
A little bit more.
On the F to the E, R, G to the I. 2.3. G, L.
Oh, wait.
Yeah.
I think that's big.
No.
Okay.
Do you have more base to it?
I thought that was the S.
So,
F
on this
to
one,
the
all you have to do is
E,
say it's
R,
balanced.
G to the I to E.
And explain why.
No, you're not.
But I spelled
I didn't think I was bad.
That's still,
Okay.
still pretty good.
I'm not gonna lie, Fergie sounds like.
Because then you can go 3 carbons.
Oh, she's got Fergie's disease.
Her real name is
It's like you have 8
Stacy.
oxygens and over here
Stacy
you
Small,
have
it's got it
6.
going
No,
on.
she's just Stacy.
And 6 is 12. So
On the
that doesn't work out. And here you have 8
I
hydrogens.
wonder if her mom
Over
had
here you have
it
12.
going.
Keep going, baby.
You can say the hydrogens didn't work out or
Yeah,
something.
they're close.
Fergie's mom is probably oldest in middles.
Hold up, check it out. Baby, baby, baby.
Okay, I need you guys to go ahead and clean up.
You kicking us out early.
Yep, let's clean up. And then we're going to get you going through one of those problems. We won't finish it all, but we'll get you going through one of those problems, okay? Because I know that you guys leave, you won't do anything, and so then you forget everything. So, go ahead and clean that up, dump everything out, and then we're going to start you doing one of those problems, okay?
We just mix it.
How much did you, Dylan, how much did you add?
I was just, what was it?
Sweet.
I was,
Wait. Got that.
11.2, maybe?
That was right, it was right around that.
It wasn't much further.
Dang it.
Let's go.
What happened is there.
Whoa, you about spilled that.
I got
She has spilled.
I got
You put those probes away, the boxes over here. Okay.
Let's read it.
Can't no lady
That's
put down like.
Let's test this sucker.
With base.
Or you guys are.
Base.
Go on, test one.
Baby, baby, baby,
What do you
if you
never
really
called it?
want it.
Yep.
1 point.
Yeah, do you want purple Kool-Aid?
Is someone who's working for me?
Good buzzer. Keep going. Get 6. Yeah. 4.6. Where's that?
Why don't you fill a beaker and dump it in the cup?
On the F to the E.
Cause I'm too dumb for that.
R to the I to the E, and can't no.
Heath and Rebecca, you got some information to fill out for the office up here. You were gone Wednesday, and then you got here.
Shoots out this thing.
What?
Got some information up here that you need to fill out. You got Wednesday, you were gone.
Sorry. I'll work it out.
I know.
How do you did this?
Let that drain out.
You've already done those two? Okay.
Move this thing.
On the F to the E, soccer game.
Went home.
Oh my gosh.
Ford, what
Your
kind of
class
scrub
mates.
are you? My God.
Yeah, Jared, where were you?
I don't know.
What am I this? He was solving the common goal.
Yes.
He was
He was solving the mystery.
taking over the world.
I'm fighting crime. Cause I am meth man. What?
How does
That
that
is
solve crime?
not school appropriate.
Are you kidding me?
That's
Half the school is not school appropriate.
Huh?
Half
Did you
the
say something?
Now you're just, that's over the top, that's too different.
Whenever I watch movies with my father,
You don't
You
like
always
it?
have to turn on subtitles for
Does
the
that kind of annoy you?
No,
Oh, that
see like that extra
What?
swell,
What if I talk like that all the time?
that was a good one, but.
Thanks.
talk like what all the time?
Because my cousin does.
Your cousin talks like that? Oh yeah, she does.